Behind every hard-looking LeetCode problem, there's a simple pattern. Here is today's pattern. We're given a string, and we're going to find a few characters that are different from the rest, and we're going to change that. And all of a sudden, we're going to get the longest repeating substring. Today, we're going to use this pattern to solve a specific LeetCode problem. The question is called longest repeating character replacement, and the difficulty of this question is medium. We're given a string s and an integer k. We can choose any character of the string and change it to any other uppercase English character. We can perform this operation at most k times, so this is our restriction. Return the length of the longest substring containing the same letter you can get after performing the above operation. In example 1, we're given a string AB, and then our k is 2, so we can change at most 2 characters in this to have the longest string. We can either change 2 A's into B's or 2 B's into A's, and then after changing them, we will have the longest string that is a length of 4. That's why our output is 4. In our example 2, we have this string and then we have k of 1. We can change at most 1 character. In this case, we're going to change the 1 in the middle, this A, into B, and our longest substring after changing that character is become 4 B's here. That's why the output is 4. So how do we solve this problem? Specifically using the sliding window technique. Let's animate one specific example to see how this actually works. So we're given a string, this string here, and then we can change at most 1 character in this. And then the final answer is 4, but we're going to see how we actually get this 4. First, we're going to initialize our left pointer and then right pointer on the first index, on the zeros index. And then we're going to use the right index to actually expand this sliding window. And we're going to expand it one by one. As we expand it, we're going to count how many characters that we store in our window. So let's expand it first. And then we just expanded and we have 2 A's. We're going to expand one more. We have 2 A's and 1 B. So we introduced 2 characters now. This is the at most 1 character can be different. So this is still okay. We're going to expand even more. We're going to expand and include A. We have now 3 A's and then 1 B. So this is still okay because we have at most 1 character that is different in this whole window. So we were still fine. But when we expand this R one more time to include B, we all of a sudden have 2 characters. That's not just 1. We have 3 A's, now we have 2 B's, but we are only allowed at most 1 character to change. So we're invalidating this entire window. So we're going to shrink from the left side. We're going to shrink this thing, and then we still have 2 characters in this, but we're only allowed 1. We're going to shrink it even more. Now we have 1 character to change. All of a sudden, this is valid again. Once it's valid, we're going to expand the right side. We're going to expand, include B, and this is still valid. We have 4 longest characters, and we're going to expand one more. Now we have 2 more. So this is the exact same as before. We have 2 characters to change to make it the longest substring. So we're going to shrink it from the left side. We're going to shrink, and we still have 2. We're going to shrink even more. We only have 1 to change, but the length is 3. So the best answer that we've seen before is 4. That's why we got answer 4. Now let's see how the code is actually written. Let's start from importing default dict from collections, and then we're going to do the definition of the function character replacement, and we're given the string s and then also the k. This is our constraint, at most k characters, and at the end we're going to report the longest substring length as an integer. First of all, we're going to initialize a whole bunch of variables. We're going to first initialize a count variable. This is going to be the default dictionary that is going to keep track of how many characters that we have inside our current window. And then we're going to initialize our left pointer, which is to the left 0. And then we're going to also initialize a max frequency. This is going to keep track of the largest the most frequent element inside our window. And then we're going to initialize our best, which is 0. This is what we're going to report at the end. And then we're going to do using our right pointer to slide. We're going to use a for loop for right our index and then our value inside this string. We're going to slide as we expand our window using this right pointer, we're going to count that character inside, and we're going to count how many times that specific character appears inside this window using the count. So we will count that, and then we will update our max frequency because we are constantly adding characters in. And then as we add in, we're going to update our max frequency. Whichever character is appearing the most is going to be appear here. For example, if A appears 3 times, it's going to be max inside our window, which is greater than B, for example. So max frequency is going to be updated. And then after that, we're going to shrink if the condition is not met. And our condition is expressed in this way using the while loop. So while our current window size, which is just right minus left plus 1, we plus 1 because we need to include both ends of the string. So this is our current window size minus, we're going to minus the max frequency that we've just calculated here. We're going to, from the entire current window size, we're going to subtract whatever appears the most. For example, in our case, A appeared many times, for example, 3 times in the first time. So we're going to minus that, and then whatever is left over is what is differing. And then that element has to be greater than K. So it is greater than K, so it is invalidating our window size, so we have to shrink from the left side. So in order to do that, we're going to first reduce the count of whatever's appearing on the left by 1, and then we're going to move the left pointer to the right by 1. So this is how we're going to shrink our window. We're going to remove, or we're going to reduce the count by 1 first, and then move our left pointer by 1 to the right. And then we're going to update our best because we just moved our left to the right, so our window size has changed, so we have to update the best window size. The best is basically best initialized at 0 before, and then our current best is basically right minus left plus 1. This is the current window size. So we will update the best, and at the end, after all of this for loop is done, we're going to just report this best. And then that's the entire logic of our code. Hopefully you mastered the sliding window technique to solve this longest repeating character replacement problem. In our next video, we're going to solve more problems using the sliding window technique. So stay tuned. If you like this content, please subscribe and check out other similar videos.